This example is providing us a table of data up top here. And from that table of data, they want us to use trapezoidal sums with 3 intervals to approximate what the number of liters of cement in the pool are at time t equals 9. So notice conveniently that t equals 9 is the last part of our table up above here. The other thing to take notice of in this problem is that we're not starting from 0 when we get to this. We are starting with 13 liters already in there. So what we'll do is we'll use our trapezoidal sums to estimate what was added on top of that 13 liters, and then just add it to the 13 at the very end. When you're doing trapezoidal sums, the first thing you got to remember is that this is coming from the area of a trapezoid formula. So the area of a trapezoid formula looks like 1/2 base 1 plus base 2 times the height. So if you're looking at your standard trapezoid that does something like this, you've got base 1 is this down here, base 2 would be this side, and then whatever that gap is right there, that's where your height would come from. The strange part about doing this that kind of messes with people's heads a little bit is when we go to put this in terms of an actual graph, we're basically tilting our trapezoid up so that our trapezoid is usually kind of doing something like this. And so what you can see here is that base 1 is really going to be the y value from the left side of your interval. Base 2 is going to end up being that y value from the right side of your interval. And the height is going to end up being down here. That's going to be your delta x. That's going to be your gap at the bottom. So you've essentially taken your standard shape and you've sort of rotated it up to the right. So whenever I'm doing Riemann sums with a table of values, I find it extremely helpful to go ahead and just pull all of that data off of the table so that it's a lot more straightforward and easy to read. So what I do is I draw out my number line here, and then I label that number line, splitting it up based upon the x values in the table. So I've got 0 right here, then my next x value would be at 3, my next x value, I know they're t's, but they're, t's, x's, all the same thing. Then it would be at 5, and then out here we'd be at 9. And then what I do is I come and I put the y values from each of those endpoints. So the y value at 0 would be 7, the y value at 3 would be 5, the y value at 5 would be 3, and then the y value at 9 would be 2. Oops, I wrote 9, I've said 2, that's the right thing. Then what I do is I label out those gaps. So I need to find area 1, area 2, area 3, and if you've done everything right, that area 3 should match up with the number of sums they're looking for. So they wanted 3 intervals, so we've got 3 areas we'll be finding, so we're right on track there. So I come back through and then I set up a sort of like, I just call it my assembly line. I've got A1 equals, A2 equals, A3 equals. And we're trying to put everything into this area of a trapezoid formula. So area is base 1 plus base 2 times the height. So come down, all of these have a 1/2 in them, right? Because that's the way the formula sets up. And then what we do now is we come back and we've got to look for our base 1 and our base 2. So remember that your bases are the y values on either side of your interval here. So on A1, base 1 would be 7, and then base 2 would be 5. The height is this gap down at the bottom here, right? The height is always that delta x, that change in our two values. Be careful on tables, because on tables they can adjust how your x values are spread apart. So these are not always equal gaps, and sometimes people just assume they are and forget to check. What we'll see on the bottom here is that this is sort of a delta x, a delta t that's equal to 3. So the height on area 1 is going to be 3. Then I move down to area 2. And so in area 2, base 1 is going to be on this left side, so that would be 5, plus my base 2 is going to be the right-hand side, which would be 3. And then my gap here this time, though, notice it's between 3 and 5. So that gap in that situation is 2 this time. So it's something slightly different. Then we go down to A3 and we play the same game. So on the left side, base 1 is going to be that left side, left y value, so 3. And on the right side, we are looking at 2, excuse me. So on the right side, we're looking at 2. And then we go to find our gap here. So the gap in between these, that's going to be a change in those of 4 this time. So you'll notice that on all of these, the gap was different. So they'll do that to you. They'll expect you to be moving a little too quick, and when you move a little too quick, then you end up just sort of missing some easy points. So now we're going to go find what all 3 of those equal, and then we'll add all of those up, and that's going to give us our total. So then at the top here, I've got 1/2. 5 plus 7 is going to be 12 times 3. So then half of 12 is 6. 6 times 3 is going to get us 18. On the next row, I get 1/2. 5 plus 3 is 8. And then times 2. So then the 2's and the 1/2 cancel out, and we'd be left with just 8 in that situation. Then going through the next one, we get 1/2 times 3 plus 2 is 5 times 4. And so here, the half and the 4 become a 2. 2 times 5 gets me 10. And now I add these values up to get the total amount that was added. So I end up with 18 plus 18, so we end up with 36. That is not our final answer though, right? Remember that we had 13 liters back up at the start here. So in this situation, we would need to add the original 13 that we had, and once we do that, we get our new total amount after 9, which would be 49. So it would be 49 liters, and that's option C. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.